Okay, so you guys, as promised, I will try to explain one more example of graphing quadratic functions slowly using two different methods that we talked about, okay? Remember, it was the long but also the best method, and there's also transformational method, which we call the add method, and then we also have the lazy method, okay? Here we go. So you guys, we have number 32 here on page 199, section 4.1, and we're going to graph this quadratic, okay? And no matter what you do, your first step should always be, right, identifying your A and your Hong Kong, okay? So in this case, your A is -3, which allows you to believe that your graph is going to look like this, right? Okay? And it's more or less going to be skinnier than your original y equals x squared, okay? Always compared to the parent, okay? And your Hong Kong is going to be -7, -8. Because remember, our original is A, x minus h squared plus k, okay? Remember, it's this and that, okay? All right, so we know it's going to start way low, okay? All right, so here's what we're going to do next. We're going to actually do method 1. Method 1, which is the transformational method. Transformer method, okay? Let's give it a name, transformer method, okay? Which means we try to use A, B, okay? All right, so let's do this. So let's list all the transformations. Transformations. Okay, what are our transformations? And we're going to do A, B here. All right, so you guys, let's do all the vertical transformations first. What's the vertical transformation here? Well, everything inside the parentheses all got to do with left and right, so it's the x, but it's going to be 3 here. There's 3. This 3 tells us that there is a vertical, let's list them, vertical stretch factor of 3, okay? So you guys, how does that change? A doesn't change, but it becomes 3b, okay? Because it gets 3 times the b value that you used to be, okay? But now, are there any reflections? Anything more vertical? Of course, there's a vertical reflection. What is vertical reflection, though? It's reflection by x-axis, okay? Remember, our graph used to look like this, but now it's flipped the other way. So I'll write that a little bit better. Okay, vertical, so we'll call it vertical, okay, or we'll call it a reflection of x-axis, okay? So that's going to be, it's going to be a -3b, okay? All right, and we have one more, -8, so it's going to be vertical, we'll call it shift, okay? Shift down 8. So it's going to be a -3b minus 8. Okay? All right, and next, but not least, horizontals, okay? Horizontal, shift, which direction? Left 7. Left 7. Okay? It's going to be a -7, -3b minus 8. All right? Alright, make sure you understand that. But you make sure you can always stop the tape, okay? Like in class, you can't stop me, but here you can, okay? Now we're ready to graph, okay? Remember, you guys, we're always going to use y equals x squared as our parent. That's going to be our main AB, okay? Let's actually write those down first, okay? So remember, we always start from the vertex, 0, 0, okay? Vertex. He's special, okay? And miraculously, this is going to come up that way too, okay? So you guys, here, we go -1, 1. -2, 4, -3, 9, 1, 1, 2, 4, 3, 9. Okay? You guys see that? Okay, good. All right, next, we're going to do y equals our graph, right? -3, x plus 7 squared minus 8, which the transformation is a minus 7, -3b minus 8. Okay? So you guys, let's actually do the calculations. What's 0 minus 7? It's -7. What's 0 times -3 and -8? It's going to be -8. And you guys look, as predicted. Okay, as predicted. All right, that's our first coordinate. 1 minus 7 is -6. 1 times -3 is 3. 3 minus 8 is -5. Okay, let's try that again. 1 times -3 is -3 minus 8. Oh, -11. Oops. Okay, -11. Sorry about that. -11. I knew something was funny. It's 4. Now let's try, 2 first. Okay, 2 minus 7 is -5. You guys already know that these go in order, right? So you can even predict this one. -8, -9, -10. Okay, Okay, because you know what? There's a shift. How many? 7 to the left. Okay? How about here? 4 times negative 3 is negative 12. Minus 8 is negative 20. Okay? How about here? 9 times negative 3 is negative 27. Negative 27, negative 8 is going to be negative 35. Okay? All right, let's try this guy. It should be, negative 11 here too, right? Because they're symmetric. Negative 11, negative 20, and negative 35. Let's try that one more time. 9 times negative 3 is negative 27. Minus 8 is negative 35. All right. So you guys, that's the first method. Okay, we have the coordinates. We just want to compare the coordinates later. But you guys, remember the other method? Let's try method 2. Method number 2, lazy 149. Okay, lazy 149. Okay, lazy 149, which works beautifully as well. Because you guys, let's write the original equation though. Y equals negative 3 x plus 7 squared minus 8. Okay, so x and y, our vertex is negative 7, negative 8. Our special point, our vertex. Okay, always start there. All right, we're gonna go a few points to the left, or to the right, and a few points to the left. All right, but now remember I said we add always 1, right? 4, 9. But we have an a involved, a negative 3. So we gotta multiply by 3, multiply by negative 3, multiply by negative 3. Okay? So let's try that, okay? What's negative 8 plus a negative 3? It's gonna be negative 11. Negative 8 plus a negative 12. It's gonna be negative 20. What's negative 8 plus a negative 27? That's negative 35. And you guys, look, are we getting the same values? Compare with your previous problem, and we are getting the same values. So we must be doing it right, okay? So here you go, and here you go. All right? And those are our coordinates, no matter what you do. But you guys, always check your values. Plug it in. What's y? When x equals negative 6, let's try, okay? Y equals negative 3. Negative 6 plus 7 squared minus 8. That's 1 squared, negative 3, negative 8. Negative 3 minus 8 is y is equal to negative 11. See? Try again. When x equals negative 5, let's see what we get. Y equals negative 3, negative 5 plus 7 squared minus 8. That's 2 squared, right? That's 2 squared. Negative 6, that gives you negative 11. Okay? So it always works out, okay? No matter what you do. And then let's graph it, okay? I'm going to graph it using this, okay? And let's actually graph it on here. It's a little limited. And let's actually graph it here, okay? So guys, we're going to graph it. Let's go here and here. This graph's not going to show all the way, but you should be able to tell me. Okay? So I start at negative 7, negative 8. So 1, 2, can you guys see? Negative 1, 2, 3, 4, 5, 6, 7, and negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, it starts there. That's my maximum. Negative 6, negative 11, that's negative 8, right? So negative 6 and negative 8, this is 8, so 9, 10, 11 here, and the symmetric here. So it should be somewhere down here somewhere. Check it on Desmos and graph it on your calculators, okay? And check it out. All right, good luck graphing. Bye.